Licensing requirements for closed-circuit television, or CCTV, installers can vary depending on the state or locality. In general, you may need a license if you are installing CCTV systems in commercial or public spaces or working on systems that exceed a certain voltage threshold, typically 50 volts. Since you are working in-house for a company, you may not need a license in your current state. However, it's advisable to check with the local authorities in Milford, Massachusetts to confirm. Low voltage certification is often required for technicians working on electrical systems below 50 volts. While 12-volt CCTV systems fall within this range, some jurisdictions may still require certification. If required, here are the steps you may need to take. Firstly, obtain a low-voltage certification. Contact your local electrical board or a vocational school to inquire about certification programs. Secondly, acquire a contractor's license. If you are required to obtain a contractor's license, you will need to meet the specific requirements set by your city or state. This may involve passing an exam, providing proof of experience, and obtaining insurance. Additional considerations involve firstly, company policies. Your company may have internal policies regarding licensing and certification for their employees. Secondly, insurance. Make sure you have adequate insurance coverage for your work, regardless of whether a license or certification is required. Thirdly, industry best practices. It's always a good idea to follow recommended industry standards and guidelines for CCTV installation, even if they are not legally mandated. It is recommended to contact your local authorities in Milford, Massachusetts and the company you are working for to confirm the licensing and certification requirements in your specific situation. It's better to be fully informed and compliant to avoid any potential issues. If you do need to obtain a low-voltage certification, firstly, research local requirements by contacting the Milford, Massachusetts Electrical Board to understand the specific requirements for low-voltage work in the area. These requirements often vary by municipality or county. Secondly, find approved training programs. Identify vocational schools or training centers in Massachusetts that offer low-voltage certification programs. Ensure the program is accredited and meets local requirements. Thirdly, complete the training program. Enroll in and complete the low-voltage training program, which typically includes classroom instruction and hands-on training. Courses cover topics like basic electricity, wiring, safety codes, and installation practices. Fourthly, pass the certification exam. After completing the training program, you'll need to pass a certification exam. The exam tests your knowledge of electrical theory, safety regulations, and installation procedures. The Massachusetts Electrical Board can provide details on the exam format and content. Fifthly, apply for certification. Once you've passed the exam, apply for official low-voltage certification with the appropriate licensing board in Massachusetts. This usually involves submitting an application form, proof of training, exam scores, and paying a fee. Obtaining a contractor's license may be required, so firstly, determine if a license is needed by figuring out if you need a contractor's license in Massachusetts. Even if you're working in-house, some jurisdictions require a contractor's license for electrical or low-voltage work. Check with the Milford, Massachusetts Building Department or local licensing board. Secondly, meet eligibility requirements. To obtain a contractor's license, you typically need to meet certain requirements, such as having a minimum amount of experience in the field, providing proof of insurance, and passing an exam. Thirdly, gain relevant experience. Accumulate the necessary experience by working as an electrician or low-voltage technician. The amount of experience required varies depending on the type of license you are seeking. Fourthly, pass the contractor's exam. Prepare for and pass the contractor's license exam. The exam covers topics like electrical codes, safety regulations, business law, and project management. The Massachusetts Licensing Board can provide study materials and exam details. Fifthly, obtain insurance coverage. Acquire liability insurance and workers' compensation insurance, if applicable. Insurance protects you and your company from financial losses due to accidents, injuries, or property damage. Sixthly, apply for a license. Submit an application for a contractor's license to the Massachusetts Licensing Board. Include all required documentation, such as proof of experience, insurance certificates, and exam scores. Other important considerations include firstly compliance with local codes. Familiarize yourself with local building codes and regulations related to CCTV installation. Ensure your work complies with these codes to avoid fines or legal issues. Secondly, continuing education. Stay up to date with industry trends and changes in regulations by participating in continuing education courses or workshops. Continuing education helps you maintain your skills and knowledge and ensures you are providing safe and reliable CCTV installations. Thirdly, documentation. Keep detailed records of all CCTV installations, including system diagrams, equipment specifications, and maintenance logs. Proper documentation can help with troubleshooting and future upgrades. Fourthly, safety practices. Adhere to strict safety practices when installing CCTV systems. Wear appropriate personal protective equipment, such as gloves and safety glasses, and follow lockout-tagout procedures when working with electrical systems. Fifthly, ethical conduct. Conduct your business with integrity and honesty. Provide transparent pricing, communicate clearly with clients, and honor your commitments. Ethical conduct builds trust and enhances your reputation in the industry. By following these steps and staying informed about local requirements, you can ensure that you are properly licensed and certified to install CCTV systems in Milford, Massachusetts. Always prioritize safety, compliance, and professionalism in your work. The requirements for low voltage and electrical work are designed to ensure that installations are performed safely and correctly. Understanding these requirements helps protect both installers and the public. When installing CCTV systems, there are several technical aspects to consider. Firstly, camera selection. Choose cameras based on specific needs, considering resolution, lens type, and environmental conditions. High-resolution cameras provide clearer images, which are essential for detailed monitoring and identification. Lens types such as varifocal, fixed, and motorized lenses offer different fields of view and zoom capabilities. Environmental conditions, including temperature, humidity, and lighting, influence the type of camera housing and features required. Secondly, cabling and connectivity. Use appropriate cables and connectors to ensure reliable signal transmission. Coaxial cables are suitable for analog CCTV systems, while Category 5 or 6, often written as CAT5 or C86, cables are used for digital Internet Protocol or IP-based systems. Ensure proper termination and shielding to minimize interference and signal loss. Power over Ethernet or PoE technology can simplify installations by providing both power and data over a single cable. Thirdly, power supply. Provide a stable and reliable power supply to all components. Calculate the power requirements of all cameras and devices to choose an adequate power supply unit. Uninterruptible power supplies, often called UPS, can provide backup power in case of outages, ensuring continuous operation. Fourthly, network configuration. Configure network settings for IP-based systems, including IP addresses, subnet masks, and gateway settings. Ensure the network is secure and protected from unauthorized access. Consider using virtual private networks, or VPNs, for remote access to the system. Fifthly, recording and storage. Select appropriate recording devices, such as digital video recorders, often called DVR, or network video recorders, often called NVR, and storage solutions based on storage capacity, recording resolution, and retention time requirements. Cloud-based storage offers scalability and remote access, while local storage provides greater control and security. Sixthly, monitoring and display. Set up monitoring stations with appropriate displays for viewing live and recorded video. Choose displays with high resolution and adjustable settings for optimal viewing. Video management software, often called VMS, can provide advanced features such as motion detection, alarm management, and remote viewing. Seventhly, lighting. Ensure adequate lighting in the monitored area to improve image quality, especially at night. Infrared or IR illuminators can provide supplemental lighting for night vision cameras. Consider using motion-activated lighting to deter intruders and enhance security. Eighthly, placement. Strategically place cameras to maximize coverage and minimize blind spots. Consider factors such as viewing angles, lighting conditions, and potential obstructions when determining camera placement. Conduct a site survey to identify optimal camera locations and ensure clear lines of sight. Ninthly, testing. Thoroughly test the entire system after installation to ensure all components are working correctly. Check camera angles, recording quality, network connectivity, and alarm functionality. Conduct regular maintenance and testing to ensure continued reliability. Tenthly, security. Implement security measures to protect the CCTV system from unauthorized access and tampering. Change default passwords, enable encryption, and restrict access to authorized personnel only. Regularly update firmware and software to patch security vulnerabilities. Some common issues encountered during CCTV installation and how to address them include: firstly, poor image quality. This can be caused by several factors, including low-resolution cameras, poor lighting, or incorrect camera settings. Ensure the cameras are properly focused. Adjust brightness and contrast settings, and consider upgrading to higher resolution cameras or adding supplemental lighting. Secondly, signal loss. Signal loss can occur due to long cable runs, damaged cables, or electromagnetic interference. Use high-quality cables, ensure proper termination, and avoid running cables near sources of interference. Consider using signal boosters or fiber optic cables for long-distance transmissions. Thirdly, network connectivity issues. Network connectivity issues can prevent IP-based cameras from transmitting video to the NVR or VMS. Check network settings, ensure the cameras have valid IP addresses, and verify network connectivity using ping or traceroute commands. Consider using a network analyzer to diagnose and troubleshoot network problems. Fourthly, power supply problems. Power supply problems can cause cameras to malfunction or fail completely. Check the voltage and current output of the power supply, ensure it meets the requirements of the cameras, and replace the power supply if necessary. Consider using a UPS to protect against power outages and surges. Fifthly, recording failures. Recording failures can occur due to insufficient storage space, incorrect recording settings, or hardware problems. Check the available storage space, adjust recording settings to optimize storage usage, and verify that the recording device is functioning correctly. Consider using cloud-based storage for automatic backup and redundancy. Some best practices for maintaining CCTV systems include: firstly, regular inspections. Conduct regular inspections of the CCTV system to identify and address potential problems before they escalate. Check camera angles, cable connections, and power supplies. Secondly, cleaning. Clean cameras and lenses regularly to remove dust, dirt, and debris. Use a soft, lint-free cloth and gentle cleaning solution to avoid damaging the camera. Thirdly, software updates. Keep firmware and software up to date to patch security vulnerabilities and improve performance. Check the manufacturer's website regularly for updates and install them as needed. Fourthly, storage management. Manage storage space effectively by deleting old recordings and optimizing recording settings. Consider using motion detection or event-triggered recording to conserve storage space. Fifthly, documentation. Maintain detailed records of all maintenance and repairs. Keep track of camera locations, model numbers, and warranty information. The National Electrical Code, or NEC, specifically Article 725.1, contains guidelines for low voltage systems, generally under 50 volts, and power-limited circuits. Article 725.1 provides requirements for the installation of Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits that are not an integral part of a device or appliance. These circuits are commonly used in CCTV systems for power and control. Some key aspects of Article 725.1 include: firstly, classification of circuits. Class 1 circuits are power-limited circuits that operate at 30 volts or less and 1000 volt amps or less. Class 2 circuits are power-limited circuits that operate at 30 volts or less and 100 volt amps or less. Class 3 circuits are power-limited circuits that operate at 30 volts to 150 volts and are subject to additional safety requirements. Secondly, wiring methods. The NEC specifies the types of wiring methods that are permitted for Class 1, Class 2, and Class 3 circuits. These wiring methods include using listed cables, raceways, and enclosures that are suitable for the voltage and current levels of the circuit. Thirdly, overcurrent protection. Class 1 circuits must be protected by overcurrent devices, such as circuit breakers or fuses, to prevent overloading and short circuits. Class 2 and Class 3 circuits are typically protected by inherent limitations in the power supply or by using listed power supplies that are designed to limit the voltage and current to safe levels. Fourthly, separation from power circuits. The NEC requires that Class 1, Class 2, and Class 3 circuits be separated from power circuits to prevent the risk of electric shock and fire. This separation can be achieved by using physical barriers, such as raceways or enclosures, or by using cables with sufficient insulation. Fifthly, grounding. The NEC specifies the grounding requirements for Class 1, Class 2, and Class 3 circuits. Grounding is required to provide a low-impedance path for fault currents and to protect against electric shock hazards. NEC Table 300.5 provides guidelines for burial depths of underground cables and conductors, which may be relevant for CCTV systems that use underground wiring. NEC Table 310.15 B16, formerly NEC Table 310.16, provides ampacity ratings for conductors based on their insulation type and installation conditions. This table is used to determine the appropriate size of conductors for CCTV circuits to ensure they can safely carry the required current. Following the NEC and other applicable codes and standards is essential to ensure that CCTV installations are safe, reliable, and compliant with local regulations. Always consult with a qualified electrician or electrical engineer to ensure that installations meet all applicable requirements.